Hello dear class 6 students, welcome back to our science class. So today we will discuss and we'll continue the part 2 fun with magnets, lesson 13. So you can all turn to page 125. So in our last class we have discussed about the discovery of magnets, the uses of magnets. We have discussed about the artificial and the natural magnet. We have also discussed about the magnetic material and non-magnetic material. And in the last class, while discussing about artificial magnet, we discussed the types of artificial magnet. Now, we have also discussed the names, right? The different names. So let's recall them, yeah. So this is a bar magnet, this is a cylindrical magnet, and this is a horseshoe magnet, and this is a ball-ended magnet, right? Okay, so students, now we will do second activity. And here in this activity, we will need all these materials, okay? And the name of this activity would be effects of magnet. Effects of magnet. Okay, so students, for this we need a clamp stand, okay, a stand. And we need a paper clip. We need a plastic or a paper cup. We need a thread. We don't need this much thread, okay? We don't need this much thread, but you can choose your favorite color. And we need a bar magnet. And we will do an activity, okay? So students, what you have to do is we will place this cup, a paper cup, here in this stand, okay? And then we will take out one thread from here and we will tie the thread with this pin, okay? And this magnet we are going to put inside this cup, okay? And we have to make sure that the others, they don't see this magnet. So after we put this magnets inside the cup, we have to cover it with paper, okay? Just paper and then cover it, because we don't want to show this magnet. We don't want to show this magic to anyone, right? Okay, so are you all excited? Let's see. So after we put the cup in this stand, it will look like this. And this is the pin. This is the pin. And here it is the thread. And inside this, there is a magnet, but we don't see, right? So we have to make sure that we don't let any other see the magnet. Now students, here we are going to see the effects of magnet. I'm sure you have seen the kite, right? How it flies, kite, K-I-T-E. So just like that, here inside this cup, since we have a magnet, and we have tied this paper clip, okay, with a thread. Okay, paper clip with a thread. Now this pin, the paper clip, will get attracted to the magnet, right? So students, what we will see, the effects of magnet that we're going to see is this pin, it will go up. Just like the kite, we'll see, okay? We'll see this paper clip and a thread rising up. No one is touching, okay? But it is going up, as if it looks like the kite is like the kite, okay? It looks as if like the kite. So students, this is the example of effects of magnet. And I'm sure you will try this activity at home. It is a very simple experiment. And dear students, one trick that I will give you. Okay, I've given you one trick, right? To make sure that no one sees the magnet, we have to cover it with paper, right? And the other trick is we have to make sure that the length of the thread is short. Okay, the length of the thread is short. So this is a very fun activity. So I'm sure you will try. Okay, and also you will see this activity in your textbook. Now, students, we will again continue with another activity. Okay, we will again continue with another activity. So you can do it with 3 of your friends who live in a different place, or you can do this activity by yourself. And at the end of this, I want to ask you a question that does the soil or sand from a given place contains particles that have iron? Okay. Now students, we all know that the iron attracts the metal, the magnet, right? So this is a magnet. Now students, we have different, okay, let's see. We have a ground, right? We have a playground in school, or we have surroundings at home, right? So all different places, they have different types of soil. Okay. So different soil will have different amount of iron. Okay. Different places will have different amount of iron. So we just want to make sure, okay, and we just want to see and we want to attract the irons to this magnet. So you can try this activity at 3 different places, okay, at 3 different places. Maybe you can try one in your surrounding, one in your neighborhood, one maybe in the garden. You can try, okay. So this is very simple. You just have to rub the soil with this magnet. Okay, we have to rub the magnet. We have to rub the soil with the magnet. Okay, let me repeat. We have to rub the soil with this magnet. And if there is any iron, small iron in the soil, it will get stick to this magnet. So in some soil, you will find many iron pieces, or we call them as iron fillings, okay? Iron fillings, F-I-L-L-I-N-G. Now, in some places, we'll find there is a little bit of iron attached with this magnet. And in some soil, we'll not find any one. It will be empty, just like here. Okay? So this is also a very easy activity, right? So I'm very sure you will try this. Now, dear students, we are going to learn about the pole of the magnet. Okay? Poles of magnet. Now, to let you understand these poles of magnet, we have activity. Okay? We have activity. And before we do this activity, let me explain what exactly is these poles of magnet. Okay? Now, just like students, we have, whenever it's a true or false, you have to answer either it's true or false, right? Or you have to say it's a yes or no. And even for conducting electric current, we need a plus charge and a minus charge, a cation and an anion, right? So like that, even magnet, they have 2 poles. 2 poles, North Pole and South Pole. We'll learn more about the poles of magnet after this activity. Now, to do this simple activity, we need an iron fillings. Okay, these are iron fillings. These are small pieces of irons. Okay, this is not a soil. These are irons, a small piece of iron, which we call iron fillings. And we need a magnet. Okay, we need a magnet, bar magnet. Now, students, what you have to do is you have to sprinkle this iron filling in a piece of paper. in a white piece of paper. White piece of paper. Just sprinkle it like this. Okay. Now you'll see them in a random manner, right? Because we have sprinkled them in randomly. But you know, when you bring this magnet, what happens? When you place this magnet in that piece of paper where you have sprinkled this magnet, sprinkled these iron fillings, okay? In a piece of paper where you have sprinkled this iron filling, you are going to place this magnet. So you know what will happen? Let's see. It will look like this. All the iron fillings will get attracted, will get stick to this magnet. Okay, and one thing you can observe, dear students, one thing you can observe from here is the iron fillings. They are not attracting all parts of the magnet, right? We can clearly make out from here that the iron fillings is not attracting the whole parts of the magnet. Why? Why? This is a magnet, then it should attract every part, right? But it's attracting only towards two poles, right? At the end, this is the first pole and this is the second pole, right? North pole and south pole. So we can see the iron fillings only in the North Pole and South Pole. Dear students, the reason is there is a strong magnetic force in the two ends of the pole. Okay? In these two ends of the pole, there are strong magnetic force. Now students, though we do not see the magnetic field lines, there are magnetic field lines. Now, if you are confused what is this magnetic field, let me tell you that magnetic field, in a very simple word, it is the area or the region where magnetic force or effect can be experienced. Okay, I'll give you an example. If you have two magnets, okay, if you bring it nearby, you'll feel that force of attraction, right? So those areas where we get the force of attraction, it is magnetic field. Okay? And the magnetic field become lesser when you take the magnet far apart, right? That means the magnetic field, magnetic effect is decreasing. So just like that, here, the magnetic field lines will be more in the North Pole and in the South Pole. Okay? So we will not see the iron fillings attracted to all parts of the magnet, but we will see them attached on two ends of the pole, which we call as North Pole and South Pole. Okay? So a magnet has two poles, North Pole and South Pole. Now, I'm sure you have understood, right, about these two poles. Now, students, it can be any magnet. It can be any magnet, but all the magnet will have two poles. I have given you the names of all these artificial magnets, right? They will have how many poles? Two poles, irrespective of their size and shape. Irrespective of their size and shape, they will have two poles. Just like here we have one pole here, we have another pole here, one pole here, another pole there, another pole there, one pole here, another pole here in this cylindrical magnet, and even in the horseshoe magnet, we have two poles here. Okay, and now students, if you break this magnet, what will happen to this pole? Okay, suppose this is a bar magnet. We have a North Pole and South Pole. If you break this magnet, what will happen? Now, even if we break this magnet, they will develop the poles. Okay, so now see, now we have a south pole there and north pole there and another south pole here and north pole there. So they develop their poles. No matter, again, if I break this magnet, again they will develop another south pole and north pole, because magnet always have two poles. If someone tells you that there are only one poles, or there is a possibility of one pole in a magnet, means it is a wrong, because magnet have two poles, that is north and south pole. Clear, students? Okay. Okay, now students, we will see another activity. Okay, so a freely suspended bar magnet, okay, a freely suspended bar magnet always comes to rest in the same direction. So we will prove this one. Now, according to this activity, it says that if we freely suspended a bar magnet, it always comes to rest in the same direction and same position. Now, this activity is very simple. You need a clamp stand. You need one stand. And if you don't have this kind of stand, you can use this chair. Okay? You can use this chair as a stand. And now what you have to do is, we'll tie the magnet with a thread. We'll tie the magnet with a thread and we'll freely suspend this in the stand here. And now, just before, we are going to rotate this magnet, okay? But before you rotate, just mark the initial position. Okay, our initial position is north is here and south is there, right? North is here and south is there. So students, mark the initial position and then rotate it. You just rotate as much as you can and see, at one point, this magnet will come to rest, right? So will it change its position? Will it change to south and north? No. Okay, again, it will give us the same direction. That is north and south. Okay, that is north and south direction. So you can try this activity. A freely suspended bar magnet always comes to rest in the same direction. Clear? Now, if you get confused, now you're trying this activity, but you're not sure whether it is north or south, then you can take example of this. We all know early morning the sun rises in the east, right? The sun rises in the east. So that means the head part of this girl is north, and then the lower part is the south, and the opposite side of the east would be west. So from here, we can also, with the help of the direction of the sun, we can also check the position. Okay, we can confirm our activity. Now students, do you know, many years back, they use magnet. They use magnet for direction. Now these days, if you get lost, it is easy, right? There are GPS, but back then it was not like this. Many years back, they used magnet to find direction. Many travelers, they carry magnet, and they perform the activity which we did. They suspend the magnet freely, because magnet will give us a north-south direction, right? And they compare it with the direction of the sun. But these days, we have a compass. Now, this compass is a device which will help us to give the direction. Okay, now inside this compass, we have a magnetized needle. We have a magnetized needle. And inside all these mark on the dial are, they have given the direction. Okay, east, west, south, north. And it is designed in such a way that we can rotate. So with the help of this magnet, also we can find direction. It is covered with glass. Okay. Now students, we can also make our own magnet at home. Okay. So we will end our class today with this activity. So students, to make your own magnet, you just need an iron bar. Okay, you need a rectangular iron bar. And what you have to do is, you have to, this is a bar magnet, okay? This is an iron rectangular bar, and this is a bar magnet. And then, without lifting the bar magnet, you have to move around from the starting point till the end point. You have to move around. Now, when you complete this round, you can leave and start all over again. Okay? So, on one end of the bar magnet, okay, what you have to do is just one end of the magnet, you have to touch the other end of the rectangular iron bar. And then, without lifting the magnet, you have to come till the end point. After you reach the end point, you can lift and then start all over again. You can do this 30, 40, 50 times. And after that, just bring a needle or a pin near this rectangular iron bar. You will see that the needle gets, or the pin gets attracted to this iron bar. Okay, so this is how you can make your own magnet. So that is the end of our class today, students. See you in our next class. Thank you.